Kia ora tātou. In this video we'll look at the final form of intermolecular forces that we need to know, which is called hydrogen bonding. We already will have looked into this a little bit in organic chemistry, but let's go over it anyway because we get directly tested on it for this topic. So hydrogen bonding will occur if we've got a hydrogen bonded to either a nitrogen, bonded to an oxygen, or if we've got a hydrogen bonded to a fluorine. So what happens is that because the difference in electronegativity is so great between hydrogen and any of these three atoms, we end up getting a really large, not quite a full positive charge, but a really large slightly positive charge and a really large slightly negative charge, but around the hydrogen and around the nitrogen or the oxygen or the fluorine. And so what that means is that when we get an adjacent molecule of whatever it is, I'll draw these in blue, why not? HO or HF. This is, so we're going to have a really large, slightly positive charge, and it's kind of the same concept as what we had with the permanent dipoles, where it's effectively just polar, polar or permanent dipole forces. But the difference is that because the difference in electronegativity is so great between those atoms, it's actually a really large force, so it gets its own category. So the most common example that you'll get of hydrogen bonding, which is really important, is water. So we've got H2O. Let's do it color coded. So O, and then we've got hydrogen molecules. And then you'd have an adjacent water molecule that has an oxygen there, a hydrogen there. And so this has got a really strong positive charge. This oxygen's got a really high negative charge, and then the interaction there is the hydrogen bonding. So if you had a question that was to ask you to describe the types of bonding that occurred between water molecules, or between a molecule that you could see had hydrogen bonding, it still has the permanent dipole forces, it still has the instantaneous dipole forces, but it has the hydrogen bonding as well. So you would need to write all three of those forces. So this means that water has got a really high melting point. In the last video we saw that ethane, CCH, has a boiling point of negative 89 degrees, whereas water, as we know, has a boiling point of 100 degrees Celsius. So that's a huge difference there. Even though this has a greater molar mass and therefore a larger electron cloud, water has a higher melting and boiling point, so these hydrogen bonds must be really strong. So they require a lot more energy to break, and therefore the boiling point is greater. So that's it, pretty quick to get through that. Practice some exam questions to be able to answer these, but that's the general idea of all three of them. Thanks for watching, see you next time.